All right, everyone, welcome back to lecture 2 of the Battlecode lecture series. Let me hide this. Okay. Cool. All right, well, I hope everyone has gotten a chance to look at the game so far. If not, that's totally cool. We're going to get into some information on, how to get set up, how to get your environment ready, how to start actually working on your bot. So hopefully if you've had any problems or haven't started yet, this will help out. So first and foremost, if you haven't signed up yet on our website, make sure you go on and register, because you'll need to do that in order to submit your code for tournaments and also for scrimmaging against other teams. So that's play.battlecode.org. On our homepage, you can sign up for an account. And once you do that, you'll be directed to this getting started page, and this is kind of where you go to get everything set up. So first thing we need to do, we need to install Java. So we say you'll need an Oracle Java development kit, specifically version 8, and that's because of the way we do our engine. We need a very specific version of Java. So we do have a link to download that. So for your platform, you'll just install that. I already have it here on mine, so we will skip this step for now. So it's important that we handle the path and class path and variables, and we'll explain a little bit more about that later. Depending on your platform, it does end up being a little bit different, but I will kind of try and indicate those steps as we go along. So once we're ready with Java, we can start downloading the actual Battlecode setup stuff, so we can start programming our bot. So there's a link to it here, the Battlecode 2024 scaffold. So it takes us here. I already have it pulled up. This is our GitHub page, and this contains all the code that you need to it's called the scaffold because it's the scaffold for your bot. So when you download this, it'll let you download our library and give you a framework for coding your bot. So to do that, simply go to this page, hit code, and then hit download zip. And that will download the zip file into your downloads folder. So I've done this here. Here it is. And then we can extract that into its own folder. So on Mac, you just double click. On Windows, you can extract. Make sure you have it extracted into its own folder. When you do that, you should see all the files in here. So we have build.gradle, Gradle, all these things in here. So I have that set up already on my desktop. So let's see what the next step is. So once everything is ready with the scaffold, we can start moving on to the local setup. So depending on your development environment or your text editor, this kind of thing, it'll be different. We've been provided some basic instructions for how to do this in IntelliJ and Eclipse, which are both two integrated Java development environments. So it makes working with Java and our build system very easy. So we definitely recommend using those if you're having any problems. So let's start with Eclipse, very common editor, and see how we can get started with Eclipse. So let me first open that. So Eclipse, so we have links to download on the page, but I already have it downloaded, so let me just open it. So it'll be prompted with this select directory as a workspace. This is not that important. You can just leave what it says by default. And here's what we see when we open the IDE. All right. The first thing you want to do is go to File and then Import. So you want to import the Battlecode project. So you have to click Gradle, existing Gradle project. So our Battlecode is Gradle. So next, and this is very important, so make sure you guys pay attention to this part. So let's actually first select our project directory. So desktop, Eclipse. So I'll select the scaffold folder as the root folder of the project. And then we need to hit next here, not finish, because we need to make sure that our Java is set to the correct version. So whichever Java you installed, so Java version 8, there are plenty of ways to figure out, depending on your platform, where it's installed to. But we have to make sure that we select override workspace settings and set the Java home variable right here specifically to be our Java home path. So basically where the Java is installed. So in this case, on my machine, this is the location. If you're on Mac, it'll probably be the same thing. So I'll put that right in there. And this makes sure that when we run the build system, it's using the correct version of Java. So hit finish, should set up the project for us. Perfect. So if I drop this down, we can see all of our tasks in here. So Gradle basically is a system that lets you run various tasks. And in here, we can see we have a little Battlecode folder up here. This is where all the Battlecode tasks will be located. So we have build, check new version, list maps, run, etc. So let me open the package here so we can see what's going on. Is this so small? Let's fix that. Okay. There we go. So we can see our package explorer here. Here's all our source files. So if I go into source, example functions player, robot player, here's the default bot that we include with the scaffold. So this helps you with all the boilerplate that you need to get set up. We'll run through this bot a little bit later so you guys have an idea of what's actually going on. But for now, we'll just skip it. So this is just the example bot. If we want to run this bot, we need to go to our task list, which should be somewhere around here. Here's our tasks. So we can build, which will build our code. Let's actually run unpack client. So this task will download the client for us so we can actually run our games. So once I do that, let me open up the code. So here, if we look back in our project folder, we can see it created a client folder right here with the Battlecode client in it. So I'm going to run this. And here is our client. So this is how you'll visualize all your games. So we distribute this with the engine and it allows you to run, visualize, see all the stats. That way you can actually know what's going on because the engine just runs the code. It's kind of hard to tell what's happening. So we can either upload a match file directly, which if you run the engine, which you can do. So let's do that first. Let's go to our tasks, Gradle, and let's click run. So you can see it running down here in the bottom right. It's running a match. Perfect. When that's done, it actually already populated for us, which is kind of convenient. So here it is. It's already loaded into the client. Here we can see our game. We can see some stats. So as I start to play, I can hit space and I can start seeing the game. So here are ducks moving around. These little arrows indicate that the duck is carrying the flag. So it's kind of easier to see. We can see on the left side the count of each of the ducks. So we have the generic ducks here. These are the attack ducks, these are the build ducks, and these are the heal ducks. And then these are how many ducks are currently in jail or out of the game. This little graph down here indicates how many units are allocated to each specialization level. So right now they all start at 0. And as they do more actions, this bar chart will change depending on what they specialize in. So let's speed up this game a little bit so we can hit these controls down here, which will speed up the game, pause the game, go to the next turn, etc. And if we can also click on hit space to pause. If we want to see what a specific bot is doing, we can click on it and it will show us some stats about it. So its ID, its health, its location, some more information like it's the amount of bytecode it's using. And if this control bar is in the way and you want to click on something, you can hit this minus here and that'll minimize it so you can click on things that are behind the control bar. One other cool feature in the client is if we click on the bot, we can see this little path and this shows us where the bot has been recently. So if I go step back 1 or 2 turns, we can see it follows along this path. So this is where you can kind of see what your bot's been up to this whole time. So yeah, that's a little bit about the client. We'll talk about that a little bit more later. Let's move on to our other IDE for right now. And so we also have some instructions for how to get it set up for IntelliJ. So IntelliJ is another IDE for doing Java. It's very good. Let's see how to set that up. So let's open up IntelliJ. We have an installation link on our website, but I already have installed. So first thing we want to do, we want to open our project. So we'll hit open, and then let me navigate to IntelliJ. And we want to select the build.gradle file. Let me just open this. And then we want to say open as project. Perfect. Here it is. So as you can see, we start out, we get a little error that says engine must be run using Java 8. This is again another issue with our computer not detecting the correct Java version. So we can fix that by going to our preferences in IntelliJ. And then we go to, where is it? Build, execution, and deployment. And then, where is it? Build tools, Gradle, and then we'll see a config for a specific project here. So Battlecode 24 scaffold. I want to make sure we set our Gradle JVM to be whatever version 8 we downloaded. So in this case, mine is OpenJDK version 1.8. So I'll set this to be that, and then I'll hit apply. So now if I try building this again, We can access our tasks from the top right little elephant icon. This is our Gradle task. So I click this. So my tasks, why is these not showing up? Hit the refresh button. Here we go. Perfect. It's configuring for us. Now, if I expand this, here are all our tasks. So again, we can see the same structure as we saw before. Battlecode folder has all our tasks in it. Here we can build, check version, run, etc. So let me just try building, make sure that works. See it down here. Perfect. Build successful. Let me get the client going. So let me unpack the client. And let me try running a match. So let's open up our bot. Here it is, robot player. Same thing we saw before. Let me get into a match here, or into the client. So same structure as the Eclipse setup. In your project directory, you'll see the client folder. Open that up. And hopefully when you go to the runner, so the runner is how you actually run games through the client. Hopefully it will automatically detect your folder and all your setup. If not, you can click this reconfigure scaffold button, and this will take you to a folder select. So all you have to do here is select your scaffold directory, hit open, and this should automatically detect all your maps and players. So right now we only have example funks player, but if we in theory had more bots we wanted to test, we could do it in here. So let's actually run a match. So let's pick two teams to run. So we'll just select them both to be this player. And then here we can select one or multiple maps to run them on. So each map is like a separate game that runs, and they're all independent. So for now, we'll just pick one. So I'll just pick small. And then this Java instance thing, this is another way that things can get messed up if you don't have the right Java version selected. So this tries to locate the correct installation. So here I can see it detected these for me. So auto should work. If this is not working for you, you can hit custom and input that same path that we did earlier into here, and that should hopefully fix the Java problem. But hopefully it should just work by default. So if I hit run, running the game, here we go, we can see my output. So each of the bots are printing some things each turn, and here we go. Game has been loaded. Hit play, and I can watch this game. Awesome. And then here's all my stats in here. And then here I can see the queue. So this is the games that have been run so far. So here I can see the players who played. I can see what map it was on, and I can see who won and why. So in this case, I won with more captured flags after 2,000 rounds. 2,000 rounds is the maximum. Let me try running one more game. This time I'll select two maps. So I'll select small and medium. This will run. Here we go. Second map is running. Awesome. Now we can replay these through these games. And here, if we look in the queue, we can see there are actually now two maps on this game. So we click the second one, we'll be taken to the second game. And here we can see this one being played. And we go back to the first one and vice versa. So yeah, that's basic setup for the client and the IDEs. Does anyone have any questions so far on anything that they've seen or encountered? Awesome. Let's move on a little bit to some more Java specific things. So kind of like a maybe review for some of you, but if you guys are new to using Java, let's talk about that a little bit. Max, would you like to come up here? Let me add in the code for you. Yeah. Refresh this. Perfect. So all the code is in here. Great. There we go. Just put that there in your pocket and then just put that up here. Okay.
Okay, great.
Cool.
Can everyone hear me? Great, okay. So, first we're going to look at some Java stuff. So, sorry, I'm pulling up the file. So here is like the most basic Java program. We have this thing at the top. So this means sorry, I'm not used to using a computer, but yeah. This thing at the top is a package declaration, and the package name has to match the folder that the Java file is in. So in this case, we have the example functions player folder, and the functions class, the functions file here, functions.java, is contained in it. So we put this package declaration at the top. And then the next thing in the file is we have these imports. These will import packages that we'll need. So there's the battlecode.common package. We do import battlecode.common.asterisk, and that imports everything from the battlecode.common package. You'll generally want to use this for your bots. And then, oh yeah, I don't know what this other one is, but and then we have java.util.random, which is for generating random numbers. So then we get to the actual program. So every program in Java is contained inside a class. This is different from languages like Python, where you can just like write print hello world or whatever. You have to actually put like boilerplate code here for Java. So we have the functions class here. And then you have methods inside the class. So the main method, which is called whenever you run the program, is this thing. You write public static void main of string bracket bracket args. So if you ever want to just like run a Java program, you have to put the code that you're running inside this function. And then we have this other method here, the test method. And this prints hello world. System.out.println is the Java version of Python print. And it just prints it to the console. And in Battlecode, it'll print it to the thing that you saw earlier on the side. So you'll be able to see it if you use system.out.println. So if we want to call the test method inside the main method so that it'll actually run, then we do that. And then we're getting an error message here. It says non-static method test cannot be referenced from a static context. And to fix this, well, notice that the main method is a static method. It has a static modifier here. And that means that it's not like connected to an instance of the functions class. It's just like a thing which is associated with the class. So for main methods and methods that are called in the main method, you might want to write static, and then there's no error message anymore. So it should work. So if we run this program, hello world, you can see right here, it works. So the next thing we're going to look at is right here. So we have another class with the main method like normal, and the print line statement here. And we're basically defining a variable that's an integer. That's what int means. And it is 100,000. Then what we're doing here is assigning it to its square. We're multiplying it by itself and putting it back in the variable. And then we're printing it. That all seems pretty simple, right? So we're running this. And then here's a result. It's this weird number. It's like 14100 something. So this is definitely not the square of 100,000. And the reason that something bad is happening here is that the number just got too big. The square turns out to be 10 billion, and that's bigger than the integers in Java can handle. So instead of integers, you have to use longs. This is just an integer with like more storage available, basically. It can handle stuff up to, I don't remember the exact number, but it's bigger than 10 billion. So this should work. If we run this now, yeah, prints the correct result. And there are also other integer data types. Like there's one for bytes, which you probably won't need. You mostly need int and long for integers. So now we're going to look at another thing involving numbers. Let's say we have a variable called robot count. It's an integer. We're setting it to 50 here. And now we want 15% of the bots to be builders. So we're making a new variable, which is the number of builders. And we're multiplying it by 0.15, which is 15%. And then we want to print this. So, oops, there's an error message. Let's look at what this says. Required type int provided double. And what's going on here is 0.15 is the double, like a floating point. Double is a type of floating point in Java. And if we multiply it by an integer, then double times integer is another double, because it's not guaranteed to be an integer. And then it's saying an error message because we're trying to set an integer variable to be a double. That is not allowed. So there are multiple ways to fix this. You can either make the variable a double. We do this, everything should work. That should give the right result, hopefully. 7.5. Sounds about right, yeah. Now, another way to fix this, if you really want it to be an integer, sometimes necessary, is you can cast to integer, which I think rounds down. So if we put int in parentheses there and put this in parentheses, then we can do this again. 7. So yes, it does round down, and this is approximately correct. So that is integer data types. This is important because like in Python, it's weakly typed. So like integers would and floating points will just convert to each other, kind of. Also, one thing to remember in Java is that if you divide two integers, it will give the rounded down result. So you need to convert one of them to a floating point if you want the accurate floating point result. Okay, so another important thing in programming is arrays. Java arrays are a little bit more complicated than Python arrays because there are multiple versions of them. The most basic type of array is just this. So you do int bracket bracket int array equals curly brace 1, 2, 3, and this will define an array of integers which contains the integers 1, 2, and 3. And then we can also just define an array without initializing it here. So the computer does not know what the value of this array is right now because we haven't given it one. But then if we try to initialize this with, let's say, 4, 5, 6, it gives an error message. Now, what's it saying? Array initializer is not allowed here. Now, in Java, for some reason, I don't really know why they did this, but you can't assign things to be expressions like this with the curly braces after you've already declared the variable. So what you need to do is int array2 equals new int bracket bracket, and then put the expression. And this assigns int array2 to be the array 4, 5, 6. Now, if we try to print an array of integers, let's see what happens. I'm going to comment out all the other print statements. Oops. You can see it prints this weird thing with random characters, it looks like. So I'm pretty sure it's actually printing some identifier which represents the location of the array or something like that. So the better way to print arrays, is to loop through them and print out each value. So we don't want to do that. And here we're accessing the 0th entry of the array. Just like most programming languages, arrays are 0 indexed. So this is the first element, which is 4. So this should print 4. Yep. So what about arrays of things which are not integers? What about strings? Well, in Java, strings are represented by the capital string class. So we do capital string, bracket, bracket, string array equals this array of strings. And to loop through an array, there are 2 options which are both used a lot. The first one is you can do just like an integer. You can increment an integer gradually from 0 up to the length -1, and then access the value at the integer. So this is the Java for loop, and then we print the value at index I for each I. And you do dot length to get the length of an array. Then we have this other way of looping through arrays for string message :string array. And then the advantage of this is it's cleaner to write. And the disadvantage is that you don't get the variable I, so you don't know what index this is. But of course you can like figure that out if you put like an extra variable in there. But if you need the variable I, this upper one is usually better to use. So both of these loops should do the same thing. And let's test this. So the array had these 4 values, and it looks like, yeah, they're being printed twice. First those 4, then those 4 again. Okay, so there's one major difference between Python arrays and Java arrays, and that is you can't really add stuff to Java arrays without making a whole new array. So like if you wanted to add the number 4 to this original int array, you couldn't just do something like int array dot add. That doesn't exist. Or append like Python. That doesn't work either. So here's what you do in Java. You instead use array lists, which are in the java.util package. So you have to import java.util.star. So you have array list and then these angle brackets. They represent the type parameter, like the type of the element. So if we want an array of strings, we do array list angle bracket string angle bracket. And then we say the variable name. And then we do new array list bracket string bracket parentheses. This calls like a constructor, which makes a new empty array. Then we can add elements, which is good. That's what we wanted. We add hello world Battlecode 2024. And then we can remove elements too. Remove world. And we can remove at an index. So if we give it the index 0, it'll remove the 0th element, which is the first. So that's hello. So now the array should only contain Battlecode 2024. And then we can also add an index, like inserting an element. So if we do add of 0, comma, the element we want to insert, that adds it at the beginning because 0 is the first element. And we can also put like 1 or 2 or any other index in there. And it adds it before that element and shifts everything over. And we can check if something's in an array, over an array list, by using the contains method. Better array that contains 2024 in this example would check if this contains 2024, and it does. And then it should print it's 2024. So let's see if it does. It does right here. Now, what if you want to initialize an array list without just like adding everything, right? Because it took 4 lines to add 4 elements to this. One way you can do that is, well, in this example, we're using integers. So you have this array of integers here, 1, 1, 2, 3, 5, 8. And we just make it like a normal array, like above. We do new integer. And because of how Java works, you have to use capital integer instead of int whenever you work with array lists, as like the type parameter and when you're doing this initialization. So you do new integer of 1, 1, 2, 3, 5, 8, like we did above, and then you plug it into arrays.asList. Arrays is also in java.util. So this converts it into a list, but not specifically an array list. So then we have to do new array list bracket integer bracket and put all of this inside that. So it's a lot longer than you'd see in another language like Python, but it works. So that's how we initialize them. And then to loop through array lists, it's very similar to arrays, except we use dot size parentheses instead of dot length. And we use dot get to access the ith element. And also, well, actually, this other method of looping through them is exactly the same. So that's nice. So let's see what this will output. So it looks like it prints. So we said for it to print the index of the number of times it's looped through so far, colon the element. And it looks like it did that. 0 is the first, 1, then 1, 2, 3, 5, 8. Good. And then we're looping through the string array this time. So it should print all the elements. Remember, we inserted the smiley face at element 0. So it's there, then Battlecode in 2024. Perfect. Are there any questions about this so far? Great, okay. One more thing. Sorry, I don't know why this isn't working. I'm trying to click on. Okay, there we go. So, there's another, this is another example of a way where, like, if you've worked with Python a lot, and then you come to Java, you might mess something up just because Java works differently. So let's say we're making a bot. So we're importing all the Battlecode packages and stuff. And so map location is a class. You probably already know this by now, but it represents the locations on the map. It takes in 2 integers as the coordinates. So we make 2 map locations here, 1, 1, and 1, 2. And we have a Boolean variable here, and we're comparing them. We're using the equals operator, which checks if they're equal. And then we print this. Let's see what happens. Is 1, 1 equal to 1, 2? False. Oh, that's correct about that. Good. Let's make them both 1, 1 and make sure it says true. Is 1, 1 equal to 1, 1? False. Oh no. So this does not work. The correct way to do it for map locations and for a lot of different types is location 1 dot equals of location 2. Good, this is true this time. And if you change it back to 2, it should say false like normal. So the reason for this is equals equals always checks if basically the memory locations of the two instances of map location are equal. And it's possible to have two equal things which both represent 1, 1 in two different locations in the computer. So dot equals actually compares the coordinates x and y, which is what we want. So what about comparing things other than map locations? Well, if we want to compare, let's say, the team of a spawn zone that you're standing on, and your robots team, basically. So in this example, we have robot controller RC and map info. We're just going to assume that like you have these from whatever code you've been writing, and map info is like the information for whatever square you want to check. So map info.get spawn zone team returns let's see, 0 if it's not a spawn zone, 1 if it's team A spawn zone, and 2 if it's a team B spawn zone. And rc.getTeam returns a value of type team, then .ordinal converts it to an integer, and that's going to be 0 for team A and 1 for team B. So we have to add 1 to check if they're equal, because these don't match. So for team A, this would be 0 plus 1, and this would be 1. For team B, this would be 1 plus 1, this would be 2. So it works. This is how we check if teams are equal. And then if we want to check if a robot is on a certain location, we shouldn't do this. We shouldn't do rc.getLocation equals equals location because of the thing we saw above. So I don't know why it's not clicking. I might be doing something wrong. Okay, there we go. So we have to do the equals. Now, as I mentioned before, this isn't just a problem for map locations. Probably for most like non-primitive types that you use, you'll want to use dot equals instead of equals equals. And here's an example where things fail. So if we use array lists, we're just initializing two exactly the same way, right? They're both hello, comma, world. And we're checking if they're equal using both equals equals and dot equals. So if we run the program, so this is from the output thing above with locations. We can ignore that for now. Down here, for equals equals, it outputs false, which is obviously not what we want in most cases, because the arrays are at two different locations in the computer. But for dot equals, it outputs true, which is correct. So, and even for strings, even though strings seem pretty simple, in Java, sometimes things can fail. So you want to use dot equals for strings. Here we go. It's some of the differences between Java and Python.
All right, awesome. So yeah, that was just a basic introduction to some of the Java concepts you'll probably need to know. Let's get into a little bit of the actual robot player that you're provided with. So let's talk about a little bit about what it's doing, and how you can change some things to get yourself started. Can I delete these? So we'll have another lecture coming up soon where we actually, I think it's tomorrow, but where we do a intro bot making. So we'll actually walk through making a bot from scratch. And so a little bit more about that in tomorrow's lecture, but for today, we'll just go through the code that we give you and see what is going on. So here's a robot player file. So this is an example function player. As Max mentioned, we always put the package as the same name as the folder we're in. And for your bots, you always need to call them robot player, just because the way we run your code, we look for the specific class to be there. So you can call the folder whatever you want, but you have to call the class robot player. So here, let's look at this. So here's some variables we keep track of. So we keep track of turn count, which keep track of which turns have surpassed. You'll notice every variable and method we have in this class is a static. And that's because we never actually instantiate an instance of robot player. We just do everything statically. So you'll need to make sure all your methods and variables are static. The way we do robots is that each robot is running its own version of this code. So it has its own robot player running. And these variables that are in here are not shared between them. So anything that you store in here will only be able to be seen by that specific robot. We'll talk a little bit more about at the end how that works, how to actually communicate with other bots. We have a whole lecture dedicated to that. I will briefly mention it at the end because we do a little bit of it in this player, but let's skip that for now. Here we instantiate a random number generator. So we need to do random a lot if we're doing, so for example, in this bot, if we don't know what to move to, we'll pick a random direction. So we'll use random to do this. And then we also include a fixed seed in here. And basically a seed just tells the number generator how to pick the ordering of numbers. So if we put a fixed seed in here, it'll always be the same every time. That way, if we keep running the bot over and over again, we'll get predictable results. We also instantiate an array of all the directions. And this is so we can pick from directions with just a number, which is very convenient. And then here's our actual method. So every bot has to have this run method. So it's public static, so we can access it. It's called run, and we pass in this robot controller RC parameter. So robot controller is the class that contains every single function you're going to be allowed to use through Battlecode. How do can I see it? Okay, I guess I can't see it in here. We can see what's in here. So in our getting started, in our resources tab, we release the specifications and Java docs for your bots. So if we look at the Java docs, this contains basically documentation for all of the information or for all the methods in robot controller or anything else you might need. So we can click on this and see everything we can do. So this is a good place to look when you're trying to figure out what your bot is allowed to do and what methods or what parameters it needs and all this stuff. And then here's a specification that I was talking about yesterday. So when you want to figure out what your bot is allowed to do and what are the specifics about what it can do, so the specification is your friend. We'll tell you everything you need to know. So let's see. So here's our run method. We can see that it has this throws game action exception here. This is also necessary. It's because if something goes wrong during the game, it will throw an exception of this type. We'll see some examples of that in a bit. So when the game starts, we print out I'm alive. So every bot will print this when it starts. And then here we have this method called set indicator string. So indicator strings are useful things that you can use in your robot. So when you set these here, they'll last for one turn. And in the client, when you click on your robot, it'll display the string as text. So this is useful for debugging some information about your robot if you want to see it without printing it out in the console. We can look at an example of this in a second. Let me open up the client and show. Let's see. So let's see if we have any matches here. So on turn one, when I spawn in, I click on this duck, we can see this little indicator variable that says hello world. So that's what this is doing right here. And then next turn, it will be cleared out. So useful debugging tool. You can also set indicator dots and lines, which are just little dots and lines that show up on the map. So if you want to visualize some pathfinding or map locations, then it makes it very convenient. And in the config, you can turn off whether or not you want to visualize these at all times. So just some things that you can do for debugging. But that's just a useful tool. Then we get into this while true loop. So you might be scared by this statement. And typically this is something that you don't want. However, for Battlecode, it's very important. And the reason is because we never actually want this run method to terminate. Once the run method terminates, your bot will explode and not be able to run anymore. So don't let that happen, which is why we have this while true loop. And basically the idea is we want this loop to run for every turn that the bot has. So right here, we can see we iterate the turn count by 1. And then we have this big try catch block. So you may be familiar with try catch from other languages. Basically what happens is we run some code in the try block, and if any exceptions get thrown, the code starts running into the catch block. So here we can see if any game actions exceptions occur, then we'll print it out. A game action exception might be anything like you try to move into an invalid location or attack a square that doesn't have a bot on it, or you try to attack too many times in one turn. Anything that relates to the game is a game action exception. So likely these, when you receive these, they will be something that you did wrong with your bot, and it's very easy to print them out and see what's going on. If you see a regular exception, this is more likely a bug in our code, so hopefully you should not see these. And then finally, what happens is either when we throw an exception or our turn is done, we've completed all our stuff for a turn, we call this clock.yield function. It's not super important to know what's going on here. This is part of the boilerplate. Basically what that means is your bot will give up its turn and go to the next one. And this is related to, we don't ever let the run function terminate. So this just has to be in here for every loop of the turn. When we're done, we want to call this function. More importantly, let's get into the actual logic. So inside of our try method, first we check for if rc.isSpawned. So as we mentioned yesterday, when the game starts out, none of the bots are spawned in, and we'll need to spawn them into one of the spawn zones before we can actually perform any actions. So we check first if it's spawned. If it's not, we need to actually spawn it. So what way we do that is we call rc.getAllySpawnLocations, and that will return us a list of map locations. So if we go look at the docs, we can see what a map location actually is. So it's an object that has 2 ints, x and y. So it represents position on the map. And so each of these is this place that we can spawn at. So for our bot, what we do is we just take a random one. So we basically call rng.nextIn. So that's this random number generator we instantiated earlier. Pick a random spawn location from the array, and we make sure that first of all, we can spawn there. And if we can, we spawn rc.spawn. And that will put our bot on the map. Otherwise, if we're already spawned, we check if we can pick up the flag. So rc.getLocation will give us the current location of our bot. And then rc can pick up flag. We'll check if we are allowed to pick up a flag where we are standing. If that's true, we call pick it up, and then we set this indicator string. So let's see if this works. So if we look at the bot in our code, we can see we start out not holding the flag, and then on turn 3, we're carrying the flag, and we can see the indicator says holding a flag. Then we have the special check for an enemy flag. So if we have a flag and our rc.getRoundNum is greater than our setup rounds. So as we mentioned in the spec, you can only carry your own flags during the setup phase. So if we're carrying a flag after that, we know it's an enemy flag. And so if we do that, we need to rush back to our side to capture it. So basically the way we do that is we get our spawn locations with the same function as before, get ally spawn locations. We pick just the first one, and we want to move towards that direction so we can actually capture the flag. So the way we do that is we call rc.getLocation. So this is where our bot is currently standing. And then we have this useful method called direction_to, and it will give us a direction. So north, south, east, west are diagonals to the location we want to go to. So in this case, the location of our spawn zone. And then if we're allowed to move in that direction, we move with this can_move and move function. So if we look at map location again in the docs, we can see this method in there. So here we have direction to distance squared 2 equals. So these are all very useful things to use when you're trying to get directions and compare locations and all this stuff. So again, Java docs, very helpful. You can access it on our dashboard. So we do that. And then we also want to move. If we can still move, we just want to move in a random direction, basically. So we're going to utilize that directions array that we had before and just basically just move randomly, which is not really a great strategy, but that's what we're doing. If we haven't moved, then we check if we are allowed to attack. So if we want to, so we pick a random direction, and if we can attack in that direction, we will attack and print out this line. Take that, damage an enemy opponent that was in our way. So again, pretty bad strategy, but just a demonstration of how you can do some basic functionality with your robot. Finally, we test out build. So here we run get location again to get our current location and then subtract the direction. So that will basically give us the direction behind the position behind where we are from a direction. And we check if we can build a trap behind us. So basically the strategy is just we're running away in a direction. We want to build a trap behind us. So here we check if we can build an explosive trap in this location. And we have some random number generator that equals 1. So this is like 1 every 37 times we'll run this code. If both these conditions are true, then we will build this explosive trap at that spot. So pretty simple there. We finally have this method called update enemy robots. So that's down here. So here's an example of just another method. We can make as many methods as we want in our class. We kind of just have to make sure we pass along this robot controller in each of them so we can run the bot functions. But here we use some enemy sensing functions. So this is the robot controller has numerous functions called sense, where you can sense things on the map. So if we actually go look at the docs, so we have sense location, or we have not these, sorry. So here's some sense methods. These will give you information about the game, about the map, about the robots nearby. So we have sense nearby robots. So we have sense nearby map info. So like if you're by water or you're by a crumb pile, it'll tell you what's nearby you. And this will return anything in a radius of this blue circle is your vision radius. So you'll get information of things in this radius. So let's see that. So you can explicitly pass a radius that you want to look nearby. So in this case, we pass -1, which indicates that we want the maximum radius, which will be the blue radius. But if you wanted to just see things that are close to you, you could pass in a specific radius. Note that it's radius squared. We have some interesting conventions with how we deal with radii in the code. But radius squared essentially just means if you want to look for 2 tiles away, you would pass in 4. But so that's this basic stuff in here. And then we check, okay, well, if there are any enemy robots nearby, then we set this indicator string where we say there are nearby enemy robots. So let's see if that's working. Let's go to a point in the code where there are bots interacting. So here we go. We can see this bot, the white duck is in its vision radius. So we can see it says there are nearby enemy robots in the indicator string. This is, again, useful debug information. And if this is true, then we get all the locations of our enemy robots. So we instantiate a new map location array. And then for each enemy robot, we set its location to its location. And then finally, here's a bit of an example of how you can communicate with your other bots. So this is the shared array. So if you look in the spec, essentially the way we do communication between intercommunication between bots is we have one giant big array of integers, and you can write values into them. So anyone is allowed to read and write values into this array. So the array is only for your teams. So each team has their own array. And you use this to communicate and send values around. So here what we do, we check if we're allowed to write this value into index 0 into our shared array. If we are, we write it. And if we wanted to read it somewhere else, we can call RC read shared array at index 0. So if the first bot that runs writes this array value, and let's say there's 5 robots nearby, then the next bot runs, they can read this value and they'll see that 5. So like I mentioned, this is the only way we can share values between robots. But yeah, so that's our basic robot player. So when that's done, we'll run this finally code, get here, and then the turn will happen again each turn. Yeah, that's robot player. Any questions about that? Yes.
So I know that certain like actions have like a noise expensive.
Mhm.
I know you mentioned the base show which you were last on that.
Mhm.
Does that also have like a light expensive in those methods?
That's a great question. So yes, I should probably talk about that. So in your bot, you're not allowed to have infinite computation. So it talks a little bit about this in the spec, but essentially the way Java works is you can think of each line of code you write has some amount of it's called bytecode, which is like little atoms of instructions that run on the computer. So the way we calculate computation is we track how many of those have run. And so different methods have different costs associated with them. And so certain methods are more expensive. And as a result, you cannot run very like algorithmically complex or large algorithms. And otherwise you'll run out of computation for that bot. So if a bot runs out of computation for their turn, their code will pause and resume next turn. So which is kind of dangerous because you might be in a state that something has gone wrong. So if you want to see how much each bytecode, how much bytecode each method costs, here's some information here. So you can see it in the Java docs. So I don't know if it shows it in the IDE. Mine's not really seem to be working right now, but in the Java docs, it does tell you how much bytecode costs each one is. So here, 1, 1, 1, 1, 1, 1, 5, 5. So this is good information if you're worried about that. And you can always check how much bytecode your bot is using by clicking on it. It tells you how much bytecode was used for that turn. And it's a little indicator here. And so you can see if you're approaching your limit. I think this year we have 25,000 is the limit for each turn, which seems like a lot, but you can definitely fill it up very quickly. But yeah, so again, JavaDoc is your friend. Make sure you're reading that. Any other questions about JavaDoc or example bot? Awesome. Well, if you have any more questions, feel free to